Today we will learn basic SQL scripting to pull information from your GP database, then also learn how to run that query inside Excel to create a refreshable Excel report. For the sake of brevity, we will assume that you have some understanding of SQL basics, such as how to make a connection to a SQL database in SQL Management Studio. In a SQL database, data is stored in tables with a defined structure. What I mean by defined structure is that there's a defined number of columns, and each of those columns has a specific purpose. Each of the columns contains the same category of data for every row within the table. So a vendor ID column will always contain vendor ID data within that table. Structured query language, also known as SQL or colloquially as SQL, is used to communicate with the database. SQL scripts can be used to control the SQL access, create, alter, or drop SQL objects such as tables or views, and retrieve, modify, or delete or insert data into the tables. To demonstrate these different functions of SQL, I've got a quick script set up here that will show each of those three different levels. If we look at this inside select statement here, this allows you to retrieve data from a table. In this case, I'm pulling some columns from the Open Payables header table. If we execute that, we can see we get some results here. If I run this whole create view script, it's going to create a new database object, a SQL view, that will create a virtual table that is the results of this select statement. So we've created that view. This grant select on statement, this is going to alter access to the PBG underscore sample view that we've created. So this will grant the ability to select data from that view to members of Dine Group. And now when we select from this view, we can just select star, which is select all columns. And we'll get the same results as when we run just that script from the inside. If we were to instead pull all columns from the PM 20,000 table, we would get significantly more data, both more columns and more rows, because we don't have the limit on the columns and we don't have the filter on the rows returned. When we select star, or all columns from the PM 20,000 table, we'll return all the columns from that table. And we can see what those columns are by looking at the table in the database. As you can see, listed under the table, we have a columns folder. And if we expand that, we're going to see the full list of all the columns defined in that table, as well as the data types associated with those columns. We can also see little key symbols beside some of these columns, indicating those are primary keys for the table, which mean those need to be unique combinations in those columns to identify a unique record in the table. If we instead look at the view that we created with this create view statement, we can similarly expand our columns and see that we have only the defined columns created when we ran that script. This is a nice way of simplifying the results that you get and only getting the information that you need when you're querying your database. As we saw in the basics overview, SQL scripts allow us to retrieve specific columns of data from a table and limit those results based on search criteria in the query. We will now go over the steps of building a query in more detail and throw in a couple more tricks like selecting data from multiple related tables using unions and joins, and then create a SQL view from our query. This demo will walk through my thought process while creating a SQL query. In this case, we will be looking to pull selected journal entry data from both open and historical year GL. The open GL table is GL 20,000 and the historical is GL 30,000. As you can see, I have used some comments within the script here. A / opens a comment block, and the * will end that comment block. If I remove the ending to the comment block, you can see all of this information turns green because it is now all just comment. It won't execute. Once I put it back, then the remainder of the select statements here become executable once more. Likewise, I have line comments after these two select statements. A line comment is this double dash. Anything after the double dash will not execute on that line, but once you go to a new line, it becomes executable once more. And then again another double dash, so anything after that on that line will not execute. And another tangential tip, you'll notice I'm not going over here to click the execute button. What I'm using instead is just the F5 key on my keyboard typically to execute the selected text. So if we run this select on GL 20,000, we'll get a whole lot of information, a lot more columns than what I'm looking to pull in this report, and of course unfiltered as far as the records go, the individual rows. If we look at the GL 30,000, we will see a similar selection of rows. Although in this case, we have very few records in the Fabricam company that are actually in history. Selecting star, which is to say selecting all columns from a table, also gives us a nice kind of visual feedback on what columns are actually available to choose from. So often when I'm building a report, I will just run a simple select like this for all columns just to see what's out there and give me a starting point for building the query. Once I've seen these, I might then limit the columns that I'm pulling. In this case, I'm going to be pulling from the open GL, the open year column, and you'll see I have an operator here, open year as year. This is basically just giving that column an alias. So when we execute this, the column name will appear as year instead of open year. So we're going to do open year, the journal entry number, the transaction date, the account index, debit amounts, and credit amounts. Now, you'll see here, when we look at the data returned, that this account index is not, in fact, an account number. It's a separate index that identifies the account number. This is a very common thing that needs to get joined into GL reports when creating custom reports and custom queries, because most of you are going to be familiar with the full account number string rather than the index. You may also notice that I've added some formatting to the query, whereas up here I have the full query on a single line. Once I've added the columns in, I set each column on its own line and also indented them and then separated the from table part of it onto its own line as well. I like to do this just for my own sanity when going back and reviewing queries. And also when building it, having these columns on separate lines makes it easy to go, well, you know what, I don't actually need this line, I'll just comment it out. And then you can run your query quickly and see what it looks like. Now we no longer have that account index. So how do we get an account number in this query that users will actually understand? In this case, what we're going to do is join in data from another table, the account index master, which includes the account index as well as the account number string and the individual segments that make up the account. So first, let's take a look at the structure of that GL00105 table. As we mentioned, we have the account index, each of the segments, and this account number string column at the end. This is the one that everyone is going to be familiar with, and so when we formulate this query, instead of putting account indexes in the return data, we're going to use this account number string. So let's take a look at how our query has changed. Down here at the bottom, I've added an alias to the GL20000 table, GLO, GLOpen, and then we've got a whole new line here at the bottom. We have this join keyword, which will allow us to join one table to a related table on specific criteria. So select from GL20000, join to GL00105, which I have an alias of AIM for account index master, on the following criteria. In this case, because both tables have an account index column, we have to make sure the query knows which account index we're referencing. That's why I have these little shortened aliases for the tables, and when we reference columns within those tables, we have to qualify it with the table, dot, and then the column name. So this join is joining the GL20000 table to the GL00105 table, where the GL account index is equal to the account index master account index. One of the results of this is that you see we have our little red squiggly line underneath account index in our column list. The reason for that is that SQL has it's a function called IntelliSense, similar to spell check within Word. In this case, it knows that this won't be able to execute properly because this column is not identified as belonging to either the OpenGL or the account index master tables. If we put a table in front of that, IntelliSense should catch up and no more squiggly line. But we don't actually want the account index table or the account index column here. What we actually want is this account number string, the reason why we're joining in the GL00105 in the first place. And we will give it an alias as well. So now when we run this query, we'll still get the same data, but now instead of having an account index, we have an account column that returns the full account number string. Let's clean up some of our previous scripts here. Just delete those guys, and that'll bring us our goal back in view, which is that we want to have journal entry data from both open and historical year. This query that we have is all well and good, but it's only pulling from GL20000, the OpenGL. So let's copy that query, paste it, and change some things so that we'll have a twin query that is pulling from the history table. First, we're going to change the table over to GL 30,000. I'm going to give this a new alias, GLH, for the GL history. And you see when I change that, IntelliSense will identify that this reference is no longer good because there's no longer a GLO table within this query. So let's update that to glh.accountIndex as well. Now this is going to reference the account index within GL history table. We see as well that open year gets underlined. That's because in the history table, that year column is not open year, but rather history year. Now I'm not actually sure what the column name is, so I am going to try and cheat here by starting to type what I think the column is going to start as. And sure enough, the IntelliSense here, it fills in available columns in GL 30,000 with hist year. So we'll use the history year. You'll see that in both of these queries, the year columns are going to come out labeled as year versus open year and history year. That'll be important in just a minute. So now we have two separate queries, each pulling data from two separate tables. Well, actually, I guess three separate tables, given that we have the account index master in there as well. If we execute both of these at the same time, we'll get two result sets. Up here on top, we have our open year data, and down here at the bottom, we have history. What we want is to get those to come through as a single result set, so a single query with a single set of results. The function to do that is called a union. Union works in joining two sets of data that have the exact same columns. So because both of our sets of data have year, journal entry, transaction date, account, debit amount, and credit amount, we can use this union function in between the two select statements. There is a modifier to union called all. The difference between union and union all is that when you add all on there, the result set will include duplicates. So if there are duplicate records between the two subqueries, the open year and history year subqueries, you'll get both records in the result. If you only have union like this, it's going to eliminate those duplicates. In this example, there shouldn't be any duplicates given that we have this year column that will be different between open and history years. So we can just leave this as union. When we execute this full query, we now get the same thing except it's a single result. Well, now that we have our journal entries, let's start filtering them. Let's say we want to filter these results on a specific account number. If we want to filter them like this and like this, you'll notice we have to do it on both subqueries. A where clause on the open GL and a where clause on the history GL. That's not too bad, but it does get annoying if you want to have this report where you can change which account number you're searching for as necessary. You don't want to have to keep coming in here and updating this where clause in both subqueries. So what can we do instead? First, let's remove our where clauses here and here. And what we're going to do is save the results of this union of the open and history GL as a view instead. So we saw creation of a view in a previous demo as well. It's pretty straightforward. All we need to do is create view, give it a name, as. So the section here, create view, the name of the view, and then the as operator. Everything after as is going to be the query that is saved as pbg_gl. I'm going to execute that. The command completed successfully. We now have a view pbg_gl. So when we do the much smaller query to select all columns from our new view, we will get the same results, the same columns, the same rows, as if we ran this whole subquery union together into a single result. This will make our life a little bit easier when we want to filter the results. Our final objective is to connect an Excel workbook to the SQL database, retrieve data using a SQL query, like one that we just worked on, refresh that data at will so that you can manipulate and analyze the results within Excel. Something that most accountants are going to be comfortable with, more so than working in SQL Management Studio. There are multiple ways within Excel to create data connections to databases. I'm just going to show you one way to do so. So starting from a fresh workbook, I'm going to go to the Data tab, New Query, From Database, From SQL Server Database. I'm going to enter the name of my server, as well as my database name, and click OK. It's going to do a search here for available tables and views within that database. Rather than scrolling through them, I'm just going to search up here, which finds our pbg_gl view that we created in the previous demo. I'll select that view. It's going to generate a preview of the data. Looks like we've got the right view. And I'll click load. It's going to begin loading in data from that query that it's just created. And once it's loaded the data, it formats it for us, identifying the header and alternating the rows with different colors. Once it's pulled that data in, we can begin formatting it, manipulating it, analyzing it, much like anything within Excel. So we can change our filter here to only filter on a single account number, throw a pivot on it to get summary amounts or just sum up values, anything like that. We can save this on our desktop here. I'm just going to call it test. And then anytime we want to use this and refresh the data, we can just go to the Data tab, refresh all, and it will re-pull our data directly from the SQL Server. If we want to edit the query directly, we can view it by going to Connections, selecting our query, going to Properties, the Definition tab, and you can see here our command text, select star from pbg_gl. If we wanted to edit that, we can do so. And now it's always going to be limited to the 000-1100-00 account. Let's recap some of the SQL basics that we have learned today. We have learned some basic terminology, and then starting from that basis, we have learned how to select columns from a table, either specific columns or all columns using an asterisk. We've learned how to select from multiple tables, either using joins to join related tables on identical columns, or unions to union subqueries with identical columns. From there, we can filter the query results using where clauses, and create a SQL view based off of a query that we've created, which will save you a lot of typing. We've also learned how to create a connection within